So, in this module, we will actually be looking at a network security tool called as a Wireshark. So, Wireshark is basically a network protocol analyzer by which I will be able to sort of find out what kind of traffic is flowing in my network and also do some amount of troubleshooting as and when required on the network. So, network protocol analyzer is basically a way by which I could capture the packet, sort of decode the complete packet including the packet header, the headers for the different network layers that has been added, and the actual application message payload that that particular packet is really carrying forward, right. So, after I decode, I would also be able to analyze the contents if I have a basic understanding of that particular protocol, right. So, a network analyzer is typically used for troubleshooting problems on the network. So, essentially if I want to find out why certain packets are not reaching a particular server, what kind of payload has actually come on a particular in a particular packet, all those kind of things I will be able to do an analysis with the typical network protocol analyzer. I will also be able to sort of try to find out wherever possible any kind of roadblocks that is preventing the network from performing very optimally, and also the network intrusion detection part of it, as well as analyzing the operations of the different network applications that could be running in my network. So, about Wireshark, Wireshark is basically a packet sniffer application that I could run on my system, and with that installation of Wireshark software on my system, I will be able to typically analyze what kind of traffic is actually flowing around in the network, and also take a look at each of the network layer headers along with the payload information containing the actual application message. So, essentially if we have heard of something like a TCP dump application, the TCP dump application is a command line tool that is available, which will sort of take the packets coming on a particular interface and dump it in a raw manner for me to really analyze what kind of traffic is actually being flowing through the network on a per packet basis. So, the Wireshark has a GUI front end, and in order to effectively do an analysis of the network traffic, it has a very powerful set of filtering options wherein I could actually filter what specific kind of traffic I want to be looking at among the entire set of traffic patterns that could be flowing in my network. Just a quick background, this was actually originally developed by an engineer called Gerald Combs, and the old name of this Wireshark product is actually named as Ethereal, right. So, you will be able to see a lot of history of this product by searching around for the Ethereal name as compared to Wireshark, because Wireshark was just recently the name of Wireshark was actually introduced for this product as recent as just a decade ago, right. So, the first version was actually released in 1998, and this has been actually a very stable product and very handy tool for network administrators effectively to use for doing an analysis of the network. So, what are the features, basic features that this software is actually providing us is understanding the structure of the different network protocols. So, here if I am basically trying to implement a new protocol as part of a stack on a particular operating system, I could actually make use of this tool to capture those packets, because when I am really implementing the protocol as part of the initial versions, I could always expect that I am going to be actually having bugs in my implementation, and this tool, because of its very effective method of capturing the traffic in a very raw manner at every byte level, I will be able to quickly come to a conclusion on where exactly is the bug which is making my implementation non-conforming to the particular protocol standard, right. So, in that way it helps me to understand basically the structure and the implementation of the different network protocols. It displays the encapsulation and single fields and interprets their meaning. So, as I was telling you right now, a packet when it is actually getting built from an application message at the higher level gets transformed into a transport layer segment, then gets converted into a network layer datagram, and then gets converted into a data link layer frame, right. At each level the packet is actually getting encapsulated with the corresponding layers header information, like we have seen in the previous module on networking. And using the tool like Wireshark, I could actually see what are the different header level metadata that has actually been added on a per packet basis, right. And that is very powerful whenever I am doing a sort of a conformance testing of my implementation, number one. Number two, whenever I want to take a look at the individual level headers metadata information when a packet is actually flowing through my network, right. This comes in handy both for the purpose of debugging a new protocol implementation that I might be trying to implement as part of my stack right now, and also it comes in very handy for the network administrators to analyze the kind of traffic that is actually flowing around in their network in order to maybe do some sort of a troubleshooting, maybe with respect to functionality or with respect to performance, right. And we also need to understand that the Wireshark being a tool that is effectively trying to display the captured packets, behind the scenes it is really making use of a library called as a PCAP. So PCAP really stands for packet capture. So there is a library called as a libpcap that is actually available as part of the packet capturing facility on any OS, right. So today this library is actually available almost on all the very popularly used operating systems. So effectively I need to have this PCAP library installed on the system in which I am actually running the Wireshark application, because Wireshark is pretty much a GUI front end application which is actually giving you a front end details on whatever has been the packets captured in a raw manner behind the scenes by this libpcap, right. So this packet capture library. So because of the fact that this libpcap has actually been ported and been running successfully on different platforms and lot of platforms like Linux, Mac, Windows and so on. So I do have this also available on all kinds of Unix flavors like Solaris, HPUX and AX as well. So on all these platforms where I have the PCAP library implemented, you will find that you could effectively run the Wireshark application without any problems, right. So the packet capture facility, it's basically a standard tool for link layer network access in Windows environment. Basically the WinPCAP is the packet capture library implementation on my Windows platform, and the features are pretty much similar to what is actually available on almost all the other platforms also, right. So it basically allows the application to capture and transmit the network packets by bypassing the protocol stack, or also including the protocol stack level details as well, right. So it consists of a driver implementation inside the operating system on which I am really running, and because of this particular implementation at a driver level, wherever required I could also have access to my network packets directly at the lowest level. So like I could even look at a data link layer frame and then give you the contents of how the frame contents really look like, as we will see in one of the screenshots later on, right. So it consists of a library for easy access to low level network layers, and that's basically different kinds of interfaces that I really have for capturing the packets and then sort of returning it to a front end application like Wireshark which is being done by this packet capture library. So for that the front end applications to be displaying the contents effectively, right. And this basically contains the Windows version of my Unix PCAP library that we were actually talking of. So if I really run the Wireshark application, this is how the user interface is going to look like, right. So before we actually go into this user interface part of it, we need to understand that for the Wireshark application to effectively capture the packets, we did talk about from a software level the availability of the packet capture library, but in addition to that, the network interface on which I am trying to capture the packets should basically be operating in a mode called as a promiscuous mode, right. Now, so what exactly is this promiscuous mode? So with the promiscuous mode, the interface will be put in a mode by which it will be able to read the packets that is actually coming across in the network irrespective of only trying to find the packets that has been destined for it to be used, right. So, by putting the network interface in a promiscuous mode, I basically get into an mechanism by which I will be able to even capture the packets that are getting into a broadcast medium and that are getting broadcasted in my network, as compared to in a non-promiscuous mode, where I will be able to have the packets delivered to me or read by me only which are actually destined for me, right. So, in other words, if the destination address of a packet, for example, is my IP address, is my network interface IP address, in a non-promiscuous mode I will be able to read only those packets, right. But whereas in a promiscuous mode, if a packet is actually coming, for example, let us say with a broadcast IP address, I will be able to also capture that packet and then get those packet delivered to my higher layers in my network stack, right. So, one of the primary requirements apart from the support of the PCAP library on the system for running Wireshark effectively is that the network interface on which I am trying to capture the packets for doing an analysis should be running in a promiscuous mode, right. So, once I basically start my Wireshark application after installing it, I need to basically decide and inform the Wireshark application what is the network interface on which I want to capture the packets. So, once I basically mention what interface I want to capture the packets, then from that instant onwards, whatever packets actually come on the network, all those packets will be captured, and this screen that you see in front of you right now will be getting constantly updated with the newly captured packets and then displayed, right. Now, if you see here, there are different packets that are getting listed, and as I was just telling, the screen will be getting continuously refreshed unless we stop the packet capture interface. If we, for example, say that okay, I just wanted to take a sample of the kind of packets that has been going around. So, this sample has been captured by this tool right now for me. So, I want to stop the capture right now, right. So, as and when we stop the packet capture, the packets will be getting captured continuously and this screen will be getting continuously refreshed, right. So, now I can basically select any packet that I want to be specifically interested, right. So, for example, let us say this is an HTTP packet and I want to find out more details about this particular packet, right. So, if I, for example, say that I select this packet here, right. So, I just click on the this particular packet, then in this particular frame of my window I will have the entire details of that particular packet, right. So, if you see here, I have the transport layer protocol. So, because this is an HTTP packet, as we were discussing before in our earlier modules, HTTP is operating on top of TCP, right, at the transport layer. So, you have the TCP related information all displayed here, right. So, you see this collapsible button. So, if I basically say that I want to get more details of it and press the button here, I will now start seeing all the metadata information associated with this packet for the transport layer header that has been added, right. So, that is basically what you are seeing here, like for example, the source port, the destination port, right, the sequence number and all this, right. So, all these details are basically the TCP related header details, right. And then if you see the next level, you have the internet protocol. So, the internet protocol is basically the network layer protocol, and if I want to see more details about the metadata that has been present as part of this IP header, I could just press on this collapsible button here, and like you are seeing the details about the TCP related header details, you will now start seeing the metadata details that has been added as part of my IP header for this particular packet that you have selected here, right. Likewise, I could see at the Ethernet protocol level and then finally at the frame part of it, right. So, I could basically see what exactly are the byte by byte contents that has actually been captured, right. So, if you see here, for example, since this is an HTTP package, the ASCII representation of the payload is basically showing you some kind of HTML tags, right. So, apparently it looks like from the payload ASCII dump, there was an HTML page that has been requested as part of this HTTP packet, and it is basically coming in as a response. That is the reason why you are basically seeing different kind of HTML tags here, like for example the slash script and those kind of things, right. So, likewise, if I basically select on any other packet I will be able to get the corresponding details of that particular packet displayed here as part of this frame, and then the payload details of that specific packet will now be coming in the last frame of my window, right. So, this is effectively how my Wireshark UI looks like in different frames, and each frame actually has different levels of details. So, if I just want to know what kind of packets have been flowing, my topmost frame of the user interface alone gives me. If I want to know the metadata details of each and every layer header for that particular packet that I have selected in the first frame, then the second frame gives me the details of the metadata at each and every protocol header level detail. Now, if I want to know more in-depth detail about the real payload of that particular packet that it is carrying, then I go into the third frame where I get the details on a particular payload message also, right. So, in that way the Wireshark user interface gives me the details of my traffic, network traffic that is flowing around at different levels depending on what specifically I am looking at. So, if I just want to get at a 10,000 square feet level what kind of packets are going out, then my first frame of the user interface itself will give me the details, right. If I want to go into the details of the header level for each and every packet that I have selected, then the second frame gives me those details, and if I want to go more in depth into find out what is the payload that is actually getting carried by the selected packet, then the third frame at the bottom of the screen gives me those details, right. So, that is basically where you should be looking at depending on what is it that you are trying to gather information by running this Wireshark application. So, the capture options are you have different options that you can basically set before the capture is enabled. So, at the first level you can specify the interface on which the packet has to be captured, right. So, if it is a Linux kind of a machine, you will have ETH0 as one of the interfaces commonly used. So, I could select ETH0, right. So, whatever is the interface name that is actually configured that I want to be capturing my packets right now, I select that particular interface here, and then I basically, if I want to apply some filter saying that I want to capture only, let us say, TCP related packets, or let us say I want to capture only HTTP related packets, that filter I could actually specify here and then say start, right. Now, what happens after this is, even though there might be 100 different type of packets that is flowing around in the network, which is actually retrievable by my interface ETH0 that I have actually selected here, and let us say out of that only 5 packets are actually HTTP packets, right. As an example, because of the fact that I have selected an HTTP or a UDP here, if there are only 5 HTTP packets that is going on out of those 100 packets, and I have applied HTTP as a capture filter here, right, and I press start, in my previous interface that I see here with the captured packets, I will only see those 5 HTTP packets alone, right. So, this kind of a mechanism helps me to sort of only concentrate on the kind of packets that I am interested in, rather than getting distracted with the kind of different packets that might be flowing around when I am not really bothered about all the different packets at that point in time, right. So, this effectively helps me to basically sort of be very specific, so that the clutter on the Wireshark output screen is minimized by specifying exactly one filter, one type of packet alone to be captured as part of my filter, right. So, there is also another way by which I could do a graphical interpretation with respect to the time. So, it basically on a per protocol basis, it also tells me from on a scale of time what kind of messages has actually been getting posted from one machine to another machine, right. So, on a per protocol basis, it helps me to understand the complete message flow that has actually happened between 2 different machines, and this is another kind of an output that is actually available in a graphical interpretation a format that the Wireshark produces on a per protocol basis, right. So, we will also have to understand what kind of things are not possible with this kind of a tool. This tool cannot be used to map out a network, right. So, I cannot really try to find out how many elements are there in my network, what are those elements, what are those IP addresses, what kind of OSs are running on that, and so on and so forth in this, because if a system is actually up and running, but it has not actually been generating any kind of a broadcast traffic, for example, this tool will not be able to capture that detail, right. So, it does not generate network data at all, It is only a passive tool where I only get details about that the packets that are originating from other machines or from my machine without this tool itself generating any kind of a packet, right. So, only shows detailed information about protocols it understands. So, if I am basically generating my own protocol implementation, right, Wireshark will not be able to capture that and then give me the details of that, right. So, it can only capture data as well as the specific OS interface on which there is a driver that is actually supported for, right. It can also be something which is actually used for capturing the data over the wireless networks, and that is something which it can definitely do, right. So, in conclusion, Wireshark's wireless analysis features have grown to be a very powerful tool because I do have lot of security and performance related problems whenever we are using a wireless networks because inherent characteristics of a wireless network. So, this tool helps me to sort of iron out and sort of determine at least some of those issues very effectively, right. So, with the Wireshark's display filters and powerful protocol dissector features, especially when I want to basically understand the kind of performance related problems on protocols that Wireshark understands, then I will basically be able to quickly come to a conclusion by applying the filter on where exactly is the problem by using the Wireshark tool, right. So, with all these kind of features it is pretty clear that Wireshark is a very powerful assessing tool and also an analysis tool both for wired and wireless networks, and it could be used typically for doing any kind of auditing or engineering or as a sort of a consultant tool that could come in handy in various kinds of scenarios. So, if I am really trying to do an audit of the network, if I am really trying to do testing as an engineer of a particular network protocol that I am implementing, or I am just trying to find out, for example, any kind of a performance or a security problem, for all these kind of purposes this tool will come in handy to give me at least the basic amount of information on the kind of traffic that is actually generated as part of the network in which this tool is right now passively listening, right. So, this is actually a free tool that you can actually download and install. As we were discussing, irrespective of whether you are actually using a Windows OS or any kind of a Unix OS, you will be able to download this tool and install it very easily because this is a very intuitive way of actually using the tool right from the installation to the initial setup and then the actual usage of it, like what we were actually seeing as part of this module, right. Thank you very much.